Hello, welcome to this class, SmartCo Academy, giving you online courses under scientists. For our today's lesson, we're going to look at trigonometry, a topic under basic mathematics. First of all, before we go into today's lesson, I'd like to ask you to subscribe to my YouTube channel and also like, comment in case of anything that you may need clarification of. SmartCo Academy will take you through. Here, trigonometry. This is a topic under basic mathematics, and we are going to look at its introduction, that is trigonometry 1. First of all, before we go ahead, we would like to list down some basic terms under trigonometry. So we have terms that we are supposed to use under trigonometry. We have one, let's say, sine theta. Two, like talk about the cosine theta. Talk about tangent theta. We also have a secant theta. Number 5, we have cosecant theta. Lastly, number 6, we have cotangent theta. Those are the terms that we are supposed to use when we're dealing with problems under trigonometry. We can also write them in short form. When you're writing sine theta, you can put it this way. We won't add s anymore, that is sine theta. Then cosine, we will just put it cos theta. Then this one also goes as tan theta. Then we have sec theta. Then we have cosec theta. And finally, that is cot theta. Those are the terms that we should use when we're dealing with problems or when we're dealing with trigonometry. So here we will also have a concept that we should do when we are solving problems under trigonometry. Let's say we have concept of. So katoa. This is a simple concept that we should put in our mind when we are dealing with problems under trigonometry 1. Let's break it down. So katoa. We start with this one. This is the first one, second one, and finally the last. Let's start with the first one, which is so. We break it down. So katoa. When we draw a right angle triangle, like this. We have our angle here, theta. Here, when we're dealing, if this one is so, this one means this S here will stand for sines. And the longest side always in this angle is always hypotenuse. It is hypotenuse. Then the opposite, or the opposite side of the angle is always the opposite itself. We put it in short, or double P. Then here remains as adjacent. This is where we are all going to find all these things of SOHCAHTOA using this simple triangle, right angle triangle. Let's start with so. That's number 1. This one stands for sines, and this one here stands for opposite. This one here stands for hypotenuse. Therefore, sine will be equals to opposite all over hypotenuse. That is the formula for sine when we're dealing it under the right angle triangle. So second thing is CAH, CAH. CAH here, we say that A stands for the adjacent, H stands for the hypotenuse, and H and O stand for the opposite. When we come to this angle here, we say that the face which is directly to the theta or the angle theta is always opposite. And the longest side is always the hypotenuse. And therefore, this one is the adjacent. Now, when we come to this one here, which is CAH, we will say that CAH is C here stands for the cos, and A stands for the adjacent, whereas H stands for the hypotenuse. So now we'll say that cos, which is C, cos theta is equals to, say that A stands for the adjacent all over H. H stands for the hypotenuse, the longest face of the angle. That is hypotenuse. So we are done with this. We are also done with this. Finally, we are going to the third one, which is TOA. Third one, which is TOA. This T here stands for the tangent, and O here stands for the opposite. A stands for the adjacent. Therefore, tan theta is equals to opposite all over adjacent. Finally, we have reached to the concept of solving or the concept of SOHCAHTOA. This one stands for the side, opposite over the hypotenuse. This one stands for the cost, adjacent all over hypotenuse. This one stands for the tan, that is opposite all over adjacent. This is not the only thing, but there are also some of the important functions of angles. When you say inverse inverse functions of angles. These are also some important things to remember when we are also dealing with problems under trick 1. So let's start with 1. 1 will say that sec theta is always equals to 1 all over cos theta. That is number 1 concept. Number 2, we have cosec. Cosec theta is equals to 1 all over sine theta. 3, we have cot theta is equals to 1 all over tan theta. And also we have again cot theta is equals to cos theta all over sine theta. Finally, we have tan theta is equals to sine theta all over cos theta. So these are the inverse functions of the angles that you should remember. And also this is the concept of the SOHCAHTOA that you should also put in mind when you're dealing with trick 1. So let's solve this one and we put it. Let's put it here. For 1, say that given tan theta is equals to 3 all over 4. Find number 1, say that find cot theta, that is number 1. 2, say that find sin theta, Then we say 3, we also find cos theta. That is an example that we should also do. Say that given tan theta is equals to 3 out of 4, we are asked to find cos theta, number 2, sin theta, number 3, cos theta. So let's start with number 1, that is cos theta. Say that 1, we have cos theta. Say that find cos theta. Here, let's go back to our right angle triangle. Let's go here, draw the angle triangle, angle theta. We say that it is tan. But tan here before we say that it is equals to what? It is equals to opposite all over adjacent. That means that this one is our opposite and this one is our adjacent. And this is the angle. The face which is directly through it is our opposite, which is 3. And down of half is what? Is the adjacent. Therefore, we don't have the hypotenuse, which is going to be x. For us to solve all these things here, we should first find the figure for the hypotenuse. Now let's do it. We say that x square is equals to 3 square plus 4 square for us to get the figure for the hypotenuse. So we say that x square will be equals to 3 square is 3 times 3, which is equals to 9 plus 4 square is 4 times 4, which is equals to 16, of which we will get 25. Therefore, x square is equals to 25. For us to remove the square, we put the root on both sides of the equation. Put root this side, also this side, and this cancels. Root 5 is equals to root 25 is equals to 5. Therefore, our hypotenuse here is 5. So now we are good to go and solve the problem. We continue from there. We say that find cot theta. Say that is our number 1, which is cot theta. So we say that when we're finding the cot theta, we say that cot theta is equals to 1 all over tan theta, or cos theta all over sin theta. So now let's take it. Say that cot theta is equals to 1 all over tan theta. Here, tan theta is given by the opposite all over the adjacent. Now let's solve it using that one. We say cot theta is equals to 1 all over tan theta is what? Is opposite all over the hypotenuse. Let's continue. We say that cot theta will be equals to 1. This one is the same as division. The same as division. We say 1 divided by. This one is same as division. Opposite. When we go here, this is our angle theta. Opposite is 3 and adjacent is 4. Therefore, we're going to say 3 all over 4. We apply the multiplication rule, then we'll get the reciprocal of this one. When we have the multiplication signs, this one goes up and this one comes down. Therefore, we're going to have 1 all over 1 times 4 all over 3. Therefore, we're still going to get what? 4 all over 3 as our cot theta. Let's continue with the second one, which is asking about the sin theta. Our number 2 is asking us about that we should find what? Sin theta. We say that sin theta here, according to this concept here, so usually represents the sign. We say that sin theta which is S, is equals to opposite over the I hypotenuse, which is letter H. Now let's go back to our triangle. Here is the theta. We say that it is equals to the opposite is 3 all over the hypotenuse. That means it is equals to sine theta is equals to 5 all equals to opposite is 3, then hypotenuse is 5. That is our number 2. Finally, number 3, asking us to find the cos theta. That is this concept. We say that cos theta is equals to adjacent. A represents the adjacent all over the I hypotenuse. Now let's go back to our diagram. We say that cos theta is equals to adjacent all over the hypotenuse. That means it is 5 out of 4. Say cos theta is equals to 5 out of 4. Come to the end of this class. In case if there is any inquiry or any clarification that you may like Smart Core Academy to add or to put across concerning this topic, you may put in the comment section. You can also drop your request there and we will be able to answer you